Dear student, this is Dr. Kamran. Today I am going to start briefing about the Clove essential oil, which is actually the first experiment of PSC 501. It is some kind of recorded briefing, and I have tried my best to explain all the concept of this experiment in a very easy way. So let's begin. In this slide, we will be seeing different experiment that we will be conducting today. So the first is the first experiment which we are going to do is the presence of oil in the plant material, right? So this is the first part of the experiment, and second experiment that we will be doing about the identification test for the clove. So it is actually adapted from the British Pharmacopoeia 2011. And the third part of this experiment is the determination of the volatile oil, which is actually based on the steam distillation method, which is actually also adapted from the British Pharmacopoeia 2011. And the last part of this experiment is the determination of moisture content by Dean-Stark method, in which we will be seeing how to measure the moisture content of the drug. So these four different subcategories of the experiment which we will be conducting in the current experiment. So let's begin. We will be seeing just about the volatile oil. So actually volatile oil usually consisting of mixture of terpenes. What is terpene? Actually it is actually unsaturated hydrocarbon with the general formula C5H8, right? So, and oxygenated derivatives such as phenols, alcohols, ketones, aldehydes, and esters. As we are knowing that the terpene is a separate topic which we will be studying in coming days. So just here we just understand that it is a mixture of terpenes, right? Because there are a number of different category of terpenes are there: terpenes, monoterpene, sesquiterpene, diterpene, triterpene, like this. So usually it is consisting of mixture of terpenes and oxygenated derivative like terpenoids such as phenol, alcohols, ketones, aldehydes, and esters, right? It is having the also a unique feature that is having the definite odor. So all that this category of drug will have the definite odor, and it is actually soluble in organic solvents. You know that there are different organic solvents are available. So these are actually soluble in the organic solvents and partially soluble in the water, right? So if you see the extraction method, it can easily be extracted with the non-polar solvent. So from the plant, medicinal plant, this volatile oil can be extracted with the non-polar solvents. There are so many non-polar solvents are available like benzene, toluene, right? And but at commercial level, which is very common in the research laboratory and as well as the pharmaceutical industry and other places, it is usually isolated by steam distillation method, right? Which we will be seeing in our coming experiment, right? So if you talk about the properties, volatile oils have a strong smell and they do not leave a permanent grease spot on the paper. So once we talk about the volatile oil, it will have the strong smell, odor, and but it do not leave any permanent spot on the paper. But the fixed oil, they can leave the spot. So this is also the difference between the fixed oil and the volatile oil. So this is about brief about properties and other things about the volatile oils. So let's move. So if you talk about the clove flower bud, it is actually the flower bud. Clear? It is actually the flower bud. Here we are seeing the dried clove flower bud. Picture of clove flower bud in the dry form. It is actually the crude drug, right? So it is actually obtained from the plant Syzygium aromaticum. Here this is the plant, picture of plant is there, and also we are seeing the clove flower bud which is present in this plant. Clear? So the biological source of this clove flower bud is the Syzygium aromaticum, which is actually available in this family Myrtaceae. So Myrtaceae is the family which provides a number of volatile oil constituent containing drugs, and having the fruity smell and some kind of unique smell. So if you see the main constituent of the clove flower bud, it is actually eugenol and having the some kind of fruity smell, right? So this is all about the clove flower bud. Now we shall proceed to see further details. So in this slide, we will be saying what is eugenol. So eugenol is actually is the major compound of the clove oil, and it actually comprising 83 to 95% of the oil. Clear? And this is the formula of this eugenol is the C10S12O2, and structurally it is like this. It is 4-allyl 2-methoxyphenol. Clear? If you talk about the boiling point, the boiling point is very high. It is 254 degrees Celsius. Density is also little bit higher than that of water, and it is about 1.06. And if you see the uses, different uses are reported, like it is used in the spices, flavoring agent, and most importantly, it is mainly used in the dental toothache in combination with the zinc oxide. So let's move. So in this slide, we are going to see the first experiment, presence of oil in the plant material. It can be done by smelling and presence and absence of a spot, right? So first experiment, just crush the drug material, clove drug, by putting in between the thumb and forefinger, and examine the presence of odor. If it is a strong odor, or some kind of pungent sweet, that means it is a clove having the volatile oil, right? So this is the first primary authentication of this clove, right? Essential oil. Second experiment, take the 1 gram of the drug material and then place in 10 ml of petroleum ether, which is a non-polar solvent, right? And warm in a boiling tube, heated on a water bath like this. Then we need to filter it and then concentrate the filtrate about 1 ml on water bath. After this, we take 1 drop of the sample, extract and apply on the filter paper, right? It is very simple step. Now let us see what is happening. If you find that the translucent area is still present, then oils are present. If the translucent area present, then oils are present. Up to here, it can be fixed oil or it can be essential oil. But from this step, we can differentiate the essential oil to the essential oil from the fixed oil. How we could differentiate? If after getting this translucent spot on this paper, we just place this paper at in the oven at 105 degree for 50 minutes. If translucent spot still present, this means this is a fixed oil. If translucent area disappear, then it is actually the volatile essential oil. Clear? So by this way we can identify the oil, whether it is a fixed or essential oil. I hope it is clear to you. So it is some kind of primary authentication of the identification of the essential oil. Let us move. So student, we are going to see the second experiment, that is identification test for the clove, which is actually adapted from the British Pharmacopoeia. And now here we are going to prepare two things. One is the preparation of test solution and the preparation of the standard solution. And for this, actually this is the TLC method. So we are also having the TLC, silica gel TLC, having the coating fluorescent material as well, and toluene as a mobile phase. Now see the how we can prepare the test solution. So first of all, we should take the drug. Here we are going to use 100.1 gram of the powder drug material and mix with the 2 ml of dichloromethane for 15 minutes and then shake, right? So this is the first step. After shaking, we need to do filtration. Once we filter, then carefully evaporate the solvent to almost dryness on a water bath, right? Up to here I think it is clear. Now this almost dry extract again dissolve in the 2 ml of toluene, because if you add this toluene, this will actually needed for the applying on the TLC plate. So now we will be getting our the test solution number first. For the standard solution number two, we just this solution we can get from the lab, and we just take 20 microliter of this eugenol and now dissolve into 2 ml of toluene. So this is ready for this. This is the test solution. Standard solution is ready. So now why we are using the standard solution? Because if you, how do you compare our test solution? So because if you apply on the TLC plate, this will give the very specific spot RA value at a particular point. So if the test solution is, if you also give the same RA value, that confirm this is the test solution is having the eugenol. So that's why we need to have the standard solution as well for comparing our results. So let us move and see in the next slide. Student, this is very important slide, and we need to see very carefully. So now we are having the two sample. One is the test sample and another is the standard sample, right? And the TLC plate of size 20 into 3. Clear? Now, how first of all understand the principle of TLC. What is the principle of TLC? Actually, TLC is a solid liquid technique in which the two phases are a solid, which is actually silica gel, a stationary phase, and a liquid, that is mobile phase. So what is actually happening? It is based on the principle that different compounds will have different solubility and adsorption to the two phases between which they are to be partitioned, right? So in case of TLC, since the silica gel is polar in nature, and once we run the sample on the silica gel, the polar material, polar constituent can adsorb first, and the non-polar will go far away from this. So in this way, the separation actually takes place, and actually depends on the solubility, solubility of the constituent in the mobile phase, right? And the separation of this constituent can be happen on the TLC plate. So this is the principle of TLC, and this way we can have the different spot. Now, second thing, we need to see how to run TLC plate. So first of all, since we are having the two sample, one is the test sample in which this is called extract sample, and the second one is the standard sample, right? So one thing is important: extract can have more than one spot. Why? Because apart from the our eugenol, other constituent may be present, but standard will always have the single spot, like this, only have single, right? So how to run the TLC? First, take the sample by capillary tube. Once you take the put capillary tube inside the solution, and then spot a spot on the TLC plate. It should be a spot 1 centimeter above to the baseline, like this. In example, in this we can see here, because if you put less than 1 centimeter, this spot can be dissolved in the mobile phase. So it should be 1 centimeter above from the baseline. Now, after putting the test sample as well as a standard sample, then and keep it for a few minutes to get it dry. It is also important. After that, we will put inside the tank jar. What is this tank jar? It is actually a jar which is in which we will development takes place. So the best thing is that we can prepare the tank 10 to 15 minutes before by putting the mobile phase inside the tank, and close the lid. Why it is 10 minutes before? Because in the 10 minutes it gets saturate the whole environment of the tank. So the spot will be more clear after this saturation, right? So the next point, once it covers about 80%, 70 to 80%, the if the solvent moves around 70 to 80%, what is solvent? Here we are having the toluene, right? So after that, we can take it out from the tank and dry it, right? And see in examine under ultraviolet light at 254 nm. definitely we will be having the quenching bands, right? And now, since in the test sample we can get so many bands, but in the standard we will have only the single band. Our task is to how would we know that this is the test sample is having the eugenol. If the test sample spot RA value is matching with the standard, that means this test sample is having the eugenol. How could we calculate the RA value? This the formula is given. RA value is distance traveled by the solute and divided by distance traveled by the solvent. So solvent generally it covers around 70 to 80%. A solid meaning whatever the solid it will cover. Suppose if it covers zero point 0.4 and solvent cover 0.8. So the 0.8, 0.4 by 0.8 is the RA value, right? In this way, we can calculate the RA value. In case of our eugenol, one example I have given here, which is already this is actually eugenol, which is from the published research paper. I am showing you just to you can get some kind of idea. Here we are having the bands of eugenol, as and sometime after spraying with the acetaldehyde and then putting it at 150 105 degree for 10 to 5 to 10 minutes. This will give more intense spot, right? So maybe the upper part you will be getting the reddish violet band and the lower part faint red in the lower part. So because acetaldehyde is a very common spraying agent for most of the natural product secondary metabolites, and it will provide the very intense intensity to the plate and the spot of the spot, right? So in this way we can confirm that this plant sample is having the eugenol because this is the RA value is matching with the standard one, right? So this is all about the TLC of this our eugenol, right? So let us move. So student, here we are seeing the determination of volatile oil, and for this we need to understand what is steam distillation, because this method is based on the steam distillation, right? So what is steam distillation? It is actually separation process and which purifies and isolate temperature sensitive materials such as natural aromatic compounds. It is actually most of the industry and laboratory they are using this method to isolate the temperature sensitive aromatic compounds such as oils. So in steam distillation, dry steam is passed through the plant material. In the boiling flask, we are having the plant material with the water. So the dry steam passed through the plant material. These vapors, because after this will convert into the vapor, undergo condensation in the condenser, and then after that they will separate into two phases and collect in the receivers. So this is the all about the steam distillation. In the coming slide, we will be seeing more in detail. So let us move. So in this slide, we are seeing the principle of steam distillation. Just now I explained about the steam distillation, and I told that it is a separation process which consists in the distilling water together with the volatile and non-volatile component, because drugs is having the both the content the volatile and the non-volatile components. So the steam from the boiling water carries the vapors of the volatiles to the condenser. So once we provide the heat to the boiling water to the boiling flask, they will actually carries the vapors along with the volatile to the condenser, where both the cooled. So after reaching in the condenser, they will cool and return to the liquid state. So condenser is having property to condense and convert it to the liquid state. So while non-volatile residue remain behind the boiling container. So non-volatile will not go inside the condenser; they will remain inside the boiling water, boiling container, right? So this is the actually principle of steam distillation, and we will be seeing how it is actually operating in the coming slide. So steam distillation can be used when the boiling points of the substance to be extracted is higher than that of water. This is the one point, and here the boiling point is Eugenol is much higher than water. So it will go through this process of steam distillation. So let us move to see how it is actually operating in practical way. So dear student, in this slide I'm going to explain about the Clove apparatus by which we can isolate the eugenol. So before going to see the process, first we should see the different parts of the Clove apparatus. This is the round water flask in which we will place the drug material plus water. This is the tube which connects the RBF to the condenser which actually carries the vapor. This is the condenser which actually condenses the vapor into the liquid phase. Here the liquid will be separated. Liquid means two different liquid phase will be separated. One is the oily phase and second is the aqueous phase. Here we can collect the oil, and this is the vent where the uncondensed gases will pass out from this. And so now the condenser is having cool water inlet from this side and hot water outlet from this side, right? Now we will be seeing the process. So in the round bottom flask we will place the 100 ml of distillation liquid, 100 ml of water as a distillation liquid, and 4 gram mixture. Mixture means if we first we take 4 gram of the drug powder plus 5 gram of drug powder plus 5 gram of dimethyl mixed together. After getting the homogeneous mixture, from there we can take 4 gram. So this 4 gram plus 100 ml of the distillation liquid we place in this RBF, right? After that we should provide the heat to this RBF. Once the RBF once we get provide the heat, the aqueous phase along with the volatile constituent will be vaporized. I'm not going to repeat the principle again because I already explained in my previous slide. So aqueous vapor phase along with the volatile constituent will get vaporized and will be vaporizing, and this will pass from this tube and reach to this condenser. So vapor along with the volatile constituent will be reaching here. So what the condenser will do? So condenser, since having the cool water inlet and hot water outlet, it will condense the vapor into the two different liquid phase. Since the two different liquid phase means one is the oily phase, that is the eugenol, in which eugenol is there, and second is the aqueous phase. Since the eugenol is having higher density, so it will be collected in the lower part of this tube and the water will be collected in the upper part, right? Here we have seen, here in this case we have seen the eugenol in the lower part, which is actually we are seeing here. Here is the aqueous part, which is actually water. So because of it actually depends about density, right? So here we can collect the water. Here we can collect the eugenol, right? So since we are doing this experiment at very small scale, so chances of getting the oil is very less, and even it is too less that it can sometimes it can mix with the water aqueous phase and floats on the top of the water. So in that case what we generally used to do, just to shake the tube, and once we shake the tube by gentle pushing, this float oil will come down and again collected in the bottom. So from there we can collect the receive the oil. So in this way we can collect the eugenol. So how could we know that the oil is getting oil is collecting? So after oil accumulation start, we can have the fruity smell, some kind of a smell. So that confirm that we are collecting the oil in the separator. After a complete 1.5 hours, we should stop this experiment and should take the reading. So in this way, we actually collect the eugenol. Xylene also helps in the actually phase separation and reading of the volume of the organic phase, that is oily phase. So this is all about the Clove apparatus by which we can collect the we can actually isolate the eugenol. I hope it is clear to all of you. So let's move. Now we are going to see the next experiment, that is the moisture content determination by Dean-Stark method. It is a well-known method by which we can determine the moisture content of the drug. and it is actually based on the principle of formation of azeotropic mixture, which actually boils at lower temperature. So first of all, we should know what is azeotropic mixture. So when the two immiscible liquids, here we are having the liquid toluene and water, which is actually two immiscible liquid having two different boiling points, and combined boiling point, two liquids combined, the boiling point will be lowered. Once we combine, the boiling point will be lower, and the two components will still separate. This is the property of azeotropes, right? So azeotropes are in the fixed composition. The mixture of two miscible liquids should be in the fixed composition, and once they mix together, the boiling point of this mixture will be lowered, and it will be the fixed. So we will be seeing in the coming slide all about the details about the toluene water. So boils at a constant temperature after reaching the azeotrope peak point. So azeotropes two components boil at the same rate. The boiling rate also be the same, and the no change in chemical state. This is the property of azeotropes. And azeotropes are very easy to distill and recover. So it is very easy to distill and recover, right? So let us move. So student, in the previous slide, we have just seen the general prospect of the azeotrope. Now in our case, we are going to see the DNA method and the liquid that we are going to use. So the azeotrope consisting of immiscible liquids. Here we are having the toluene and water. Toluene is having the boiling point at 110 degrees Celsius, and water is having boiling point 100 degrees Celsius. And they actually do not mix well at room temperature. That's why it is immiscible. But once they form azeotrope at a lower temperature, the temperature will be 84 degrees Celsius. They can boil at this temperature. So after formation of the azeotropic mixture, the boiling point will get reduced, and it boils at 84 degrees Celsius, right? So after this, once they boil, the vapor will reach to the condenser, right? So what the condenser will do, they will actually separate back into the two separate phases. So so in this way we can collect the aqueous phase and note down the water content, right? So it is actually also helpful in removing water from the organic solvents. So this is all about the method of the star, what we are going in our current experiment. In the coming slide, we will be seeing in detail how it is actually operated, this linear stark method, by doing experiment, right? So let us move. So here in this slide, we are seeing how Dean Stark apparatus is working practically. As we are knowing that we are having two types of solvent. One is the water, and the second is the organic solvent, that is toluene, and they are having two different boiling point, right? And their densities are also different. Toluene is lesser density and water is higher density, that is one. So they will actually form the azeotropes, and they can vaporize at the lower temperature, that is 84 degrees Celsius. Now we can see first what are the different parts. This is the round water flask, right, in which we will keep our water, drug, whatever the material is there. This is the tube which connect, and this from here the vapor will pass through this and reach to the condenser, and the condenser actually condense the vapor into the liquid phase, and here the liquid phase will be trapped, and we can measure here the reading. We can take reading from this side, from here. So this is the basic parts of this then Stark apparatus. In condenser, here the water inlet, and from where we can this cool water will pass, and the hot water exit also there. From the hot water will pass from the condenser. Now we see the experiment, how it is operated, how it will be operated. First of all, we need to prepare first the blank test solution. Then we will determine the H2O determination in the crude drug. For the blank test, take 120 ml of toluene in this 120 ml toluene in this flask, 250 ml of this flask, right? and then add the boiling chips. What is the role of boiling chips? Actually, it prevents the bumping, right? And then we will add 1 to 1.5 ml of water, and then distill, and we should provide the heat from here. And once we provide the heat, it will convert into the vapor, because and it will rise at what temperature, that is 84 degrees Celsius, and the vapor will pass through this side and reach to the condenser. So condenser actually condense the vapor into the liquid, and this again to biphasic liquid, that is organic and aqueous, will be trapped here, right? So we can measure the volume of water, because we are having the organic phase, that is toluene is there, which is organic and which is on the upper part, and the water will be in the lower part. So we can measure the volume of water, right, from in this burette. Now it is, suppose it is XML. Now our task is to calculate the water in the crude drug. So what we need to do, once we run this for 30 minutes and take the reading from here, that is X. Now we should cool down this flask. After cooling it, then add 10 gram of crude drugs in this flask, and because we should not throw out, do not make sure that we should not throw out this all the things. We should take and cool it, and then add 10 gram of the drug material, and then distill it for 45 minutes. After providing the heat, again this will be vaporized, and the vapor along with this vapor actually carries and reach to the condenser, and here this condenser will condense this by into the biphasic. One is the aqueous phase and the another is the organic phase. So definitely the organic phase will be on the upper side in this burette, and the aqueous phase will be in the lower part. In this case, we can also again we will measure the reading of water aqueous phase. So in this case, the reading will be more. Why? Because this drug may be some kind of moisture is there. This will again vaporize, and this makes the reading higher, right? So this measurement definitely will be higher. So if you again measure this aqueous layer, aqueous reading of the this content, and you should note it down as a Y. So if you calculate the drug content, what is required, this Y that we have collected after adding the drug in this round water flask minus X without having the drug material. So if you minus the X from the Y, this will show the water content in the drug material. So in this way we can also calculate the percentage value, right? So I think it is clear to all of you. I am explaining in a very simple way, and this is the way by which we can calculate the moisture content through by Dean-Stark method, right? Clear? So dear student, this is all about the practical briefing of this essential oil, and I hope that all the content might have clear to all of you. If still any query questions, you may directly contact to us. Thank you very much.